Hello, everyone. Welcome to another Caffeinated Quality. Today, I am handing over the reins of moderator over to our board member, Paul Hayes. So I'm going to hand it over to him and let him take over. And welcome, Paul. Welcome, everybody else.
Thank you very much, Gwen. It's really a pleasure to be here, and it's just like I'm happy to be able to support AST in this way. Today's topic is for caffeinated quality is all tests passed. This is true and worthless. So it's just like I've broken this section down through different topics. So we're going to have about 5 different things to go. We're going to go over green dashboards, systems, oracles, and then something that's quite interesting is called counterfactual testing, and then we'll have a little bit of a wrap up. But before we get moving in, it's just I'd like to introduce our guests, and first we'll start with Paul Gariboldi. Paul, you spent years at Google advising the world's largest banks and retailers, and by your own proud confession, you are not a techie.
I am actually very proud to say I'm not a techie. I reserve being a techie to the really smart people, of which I'm not. So Gwen, Doug, nice to meet you. Paul, everybody, thank you very much for the invite. Yes, Paul, I spent the last 7 years working at Google Cloud. And it was an interesting transformation, which I think can have a direct impact on the conversation that we're going to have today, right? So my first several years there was talk of AI, but not that much. The real talk was around a category called digital transformation, which you hear less of today. And today you hear much more. Almost everything we read and hear about has to do with AI. And I think with this new category of safety automation, I think a lot of things that we're hearing can directly apply to this live stream that we're having today. So before that, I did a bunch of startups. I worked with a company called OTG back in the Web 1.0 when you had to explain to people what the World Wide Web was and why they needed a website. So I go back a few years, and I'm delighted to be here, Paul. Thank you so much for the intro and the invite.
Thank you very much, Paul. I have one question for you. What's
Sure.
the one thing in your house that you refuse to automate?
I was afraid you're going to ask me that question. So when you look at AI agents and AI models, right? You have to remember that there's actually people behind that actually writing those, right? And they're writing the code on the back end of that. So I'm reluctant to give up my personal finances to it. Right? There's been a lot of examples that I've read about where you can take the exact same question or task, give it to an AI agent, or give it or try and work with a model, and you get different results with the exact same question, right? So when it comes to my money, and I guess I'm showing how cheap I am. When it comes to my money, that's one thing I don't want to give up.
Thanks. Sounds like a great thanks. Joe,
Okay.
welcome
Paul.
very much.
Thank you.
2 decades at Cisco, and now you're working on the governance side. So tell us a little bit about yourself, and I got a follow-up question for you too.
Oh, certainly. Well, I started off in financial services, and I was on the secondary marketing side of things, so creating mortgage-backed securities and trading mortgages and things like that. And the natural path towards that is to go to a Wall Street firm like a Morgan Stanley or a Merrill Lynch. I chose to go the technical route because I had an opportunity to do some technical improvements within the business unit that I was managing, and I just loved it. So I just steered myself more towards tech and implemented applications that supported the functions that I was performing prior, and then ended up at General Electric for a while, did a few startups, and then ended up at Cisco for about 15 years doing a variety of projects across a variety of business units. And that was very, very rewarding. Cisco's a great company, very diverse. So it gave me opportunities to work in a lot of interesting areas.
Excellent. Thanks. So what's your favorite car?
Oh, well, I'd have to say a Corvette. When I was a younger man, I had a 65 Corvette Stingray. I loved that car to death. And now that I look at the modern Corvettes, the current model is called a C8. It's a phenomenal car, and the value that you get for a fraction of the price you'd pay for, a Lamborghini or a Porsche or a McLaren. It's just a wonderful car. So that's my favorite.
I would still take an Aston Martin, but we can just haggle over the price. Okay. Thanks very much, Joe. I'm glad you're here. Michael, you're an AI specialist and you build the agents everyone else here worries about. So tell us a little about yourself. And I have a question for you too.
Yes, thanks. Thank you, Paul. Well, I'm a senior solution architect with over 20 years of experience. I spent the largest portion of my career in enterprise software, IT security, database management, leading a team, Java, and so on. And recently I founded together with my colleagues a solution to do safety automation, a startup where we built safety and resilience automation for OpenShift environments.
Mm-hmm.
Further, as you probably all here heard already, I'm Austrian. That's why I speak like Arnold. Yeah, my accent. I'm sorry. I hope you can understand me. Actually, he grew up some miles down the road here, but that's a different story.
Yeah. So you're in a bordering town from Arnold Schwarzenegger.
I wouldn't call it that, maybe.
Okay, I have a question for you, and I want your honest opinion. It's just like humans in the loop. Is it a necessary safeguard, or is it training wheels will outgrow?
Oh, I tell you honestly, with my background in security and resilience testing, I do not see humans in the loop as training wheels at all, but actually as the core counterplane. How to say, where machines actually excel is optimizing bounds. But where humans excel is handling context to it, isn't it? And judging on context. So if you design an AI agent to execute actions where humans are just rubber stamping and bystanders, you haven't built a safeguard. You built an automated scapegoat, isn't it? So we won't outgo human at all. We just have to shift the human's role from manual driver to more system supervisor. So actually, to use those systems, to test the systems, but humans are still in control. That's very important.
Okay, thank you very much.
Ooh, I want to throw one out there because it was interesting. I was actually just doing some research on this last night, and did a post on a report that just came out from Splunk around, the AI that's been implemented to improve resiliency, to get out there and monitor systems, right? And there has been a 50% increase in downtime for these teams who have implemented. So massive challenge, right? You implement the tech, you put your faith and your confidence in the tech to have the types of mechanisms in place to check itself and to do do the checks and balances and do the monitoring and doing all the stuff that we need to know to make sure that everything's okay, and then it goes wrong. So how are you guys approaching that problem, right? Because that's obviously we're at a hurdle here now to get over. And how do we do it in a way that like allows humans to one, not lose faith in the tech and just pull it out of their systems, right? So yeah, how are you all approaching that?
Well, I think the most important thing is that the proper context gets injected and tested. I can give you an example from our last evaluations test runs we had. There was an agent that was there to prune and delete unused databases in the cloud. Developers create a lot of databases all the times, and then this data in the cloud and just produce costs. So the objective was that all databases that weren't used for 30 days should get deleted. And the agent did it one day, as supposed, because there wasn't for 30 days some traffic. However, what was overseen was that this actually was the standby backup database in case of a severe incident. So, I mean, the agent did as defined, and they worked properly. But I mean, one could say, you know, the context given, the context or the agent was set up wrongly because the context was missing. Given the context wasn't given to him, but the human had recognized that. A human had recognized this is a standard database, and I should not delete it. This is the exception to the rule. So I think there has to be there has to be done a lot of context injection and testing for context, that so-called famous AI rubrics that are now named everywhere.
I think that's an excellent question, and it's an excellent segue into the first part of our program. It's like, what does green actually prove? You know, it's just like, Paul, I'm sure you've been in hundreds of launch reviews. You never read a line of code because that's not your strength, and someone says all tests passed.
Mm-hmm.
What did you believe?
So first of all, you're right. I've never read a line of code or written a line of code in my life, but I've been in a lot of situations where I've had teams developing different types of applications, right? Either building one application that's critical to the business that they're going to launch, or multiple applications, or in other scenarios where you have one application being launched that is affected by or interacting with multiple other applications, right? So the number of potential things that can go right and go wrong are countless, right? So my experience is simply this, Paul. I'm in a meeting. I have people working for me. They're talking about, they're ready to go. They're publishing systems. And I remember one thing from many, many years ago, and that is simply that software essentially is a living, breathing organism and can be affected by other living, breathing organisms or other applications, right? So for me, the only way I would believe it, okay, because the only way I believe it is it was published and it worked flawlessly, which was not the case most of the time, because they were not testing for, they weren't doing any sort of counterfactual testing back in those days, right? So what would happen, Paul, is, and it almost happened like all the time, there would be a problem that they hadn't planned for, right? Because they didn't have the mechanisms that are available today, like the safety automation tool set that Dynacove offers, where you can actually do this counterfactual testing and actually look for problem areas prior to. So remember, one of the key things that I always look for, yes, of course, I was looking for the benefits of what those applications would do, right? I wanted to see how much money we would make or how much cost savings we would have. But what I was really looking at was, what was my risk assessment? Like, if it published and didn't go well, what was the level of risk and what was it going to cost me to get it fixed? So I don't know if that answered your question there, Paul, but That's typically what I encountered as an executive and working for companies like Google Cloud.
And did there come a point when there was something that you would just say, well, I don't believe it anymore?
Yeah, I mean, pretty much. It's a very good question. The point of not believing it was most of the time when we were getting ready to launch, right? Because invariably what would happen, Paul, is they'd launch, okay?
Mm-hmm.
And everything was green on their dashboards, right? They'd show me they
Yeah.
ran these QA tests, they ran these other testing applications, they did this and that. Everything was green. Voila, something goes wrong. Something went wrong in the main application or an associated application, or something went wrong in one application and affected the outcome of the others. I'm sure at some point you all talk about CrowdStrike, where a simple update happened back in 2024, and that update actually brought down the market. I mean, because of the multiple occasions, affected thousands and thousands of customers around the world that were reliant on CrowdStrike. How one simple software update affected thousands of clients. I mean, literally hundreds of thousands of clients across the world. And coincidentally, so as you mentioned, Paul, I'm on the business side. So if I'm on the business side of that issue, CrowdStrike's market cap declined by multi-billions of dollars, literally within hours, not in a day, within hours.
Wow.
Yeah, and it was one line of code, wasn't it? Like it was an out of bounds.
It was one line of code, which they actually fixed, Gwen. I mean, eventually they fixed it.
Yeah.
And by the way, as being on the business side, I read it was an upgrade, but everybody in the markets, right? The trading markets, all the customers, they were reacting to the CrowdStrike application doesn't work, when in fact it was a line in an upgrade.
Yeah.
Right. So you watch the world and how the world reacts. And if you're on the business side of it, it's not so important what the actual problem was. It's how the world reacted to it. Now, I'll give you one little side note, Gwen, that I observed. Of the hundreds of thousands of companies that were affected, only one actually sued, and it was Delta Airlines. It was the only company that actually sued, which I believe is still in litigation today. My belief is they're not going to win, and the reason is simple. Because in every software contract, there's an indemnity clause, right? Which basically says you use the software at your own risk, and you can't hold us harm if something goes wrong, right? But that's a really good example. I may have jumped the gun on your agenda there, Paul, but that's an example. So as a businessman, this is what I would see on the impact side, right? So being on the executive side, Paul, I'm publishing applications, or I'm being part of applications, or new features being built into, say, products, okay? Everything's green. We roll them out to customers. Everything's not green, all right? So there's a huge business impact. Now, unfortunately now, with this new category, which I think we're labeling safety automation, we can actually do a lot to alleviate those types of potential problems.
Okay. Thanks. I'm going to move to Joe. I have a question for him. It says Joe, based on, try that again. Anyway, Joe, the green dashboards prove exactly what you asked. The silence is where the risk lives. Was there a day that sentence stopped meaning anything to you at Cisco? That everything's green.
Yeah, I worked for a while in our authorization product business unit. So we had our own authorization platform, and you don't hear about problems until after they've already happened and multiplied, and we had a lot of people that were not able to log in, and so there was a lot of complaints coming in that, hey, we can't log in, we've been trying, we can't log in. Well, it turns out, Cisco has very rigorous testing standards and quality assurance standards, and so in our mind, when we implement something, everything works. Well, apparently, and the postmortem on that was a database started to slow down, and so when that happened, some of the authorization requests didn't happen. And so the gateway is designed in such a way where you do a retry. Well, if you got a bunch of people logging in and the database is slowing down and they can't log in and you got all these retries happening, now you've got this compounding effect of retries that are basically creating a self-inflicted denial of service scenario. And so it was kind of a ripple effect that no one anticipated. Nobody tested for that. It was just we had procedures in place. Database slows down. The gateway does what it's supposed to do. Everything's supposed to work. But in this case, it didn't.
But it's just like that's. I mean, I think we've all seen that a lot. It's just I just have one question. Like, what did a good test report look like at Cisco? And did anyone ever get past page 1?
Well, there's, there would be waves of testing, and there's all the systems testing, all the business acceptance testing, the user acceptance testing, and they're all looking at different things. Sometimes there's a little bit of overlap. And when all of those things come in green, the assumption is everything's going to work, but then it all goes into production and things still break. And it's hard to point your finger at any one thing that could be corrected to mitigate that kind of risk, because everybody's raising their hand saying, well, I did my job, my test, I can show you my test results. They all passed. So individually, everybody seems to be doing their job and meeting the acceptance criteria. But then collectively, who really owns that? That was a question that I had, was who owns the big picture? Because you've got a lot of individual components with their individual teams and they all think they're doing the right thing. But, who owns the big picture? And a lot of people will point to the executive and say, well, you're overseeing this. This is something you need to take care of. But it's not something it's not something in their wheelhouse. So it really does not get effectively addressed.
I would like to interject and a strong opinion about the green light release criteria for a number of reasons. I've been playing with computers since punch card days, and hardware design, software design, operating systems, device drivers, applications for a long time. But when you get a green light, what's that mean? It means that you ran a test that's been run before, and therefore the code has been trained to pass it, and you didn't notice anything. Doesn't mean that what you thought you tested actually works. You just didn't notice whether or not it worked. And so a green light doesn't mean anything, really. A red light tells you that somebody has to investigate. But other than that, you're going to let the code do what it does. And lots of examples. We haven't tested everything. Does it have memory leaks? Did it go out and talk to files that it shouldn't be touching? Did it use up bandwidth that it shouldn't be taking up? Was it too slow, too fast? It just, the number of things that we're not testing is huge compared to the few things that we are testing. And we're testing things poorly. because we've trained the code to pass the test. Anything that we found in these regression tests has already been fixed, right? And so they're doing the same thing over and over again, and you're expecting a different result. The regression tests were created because people had individual copies of the code way back when. And I would check in my code, which would clobber somebody else's.
Yeah.
You know, they put in a fix, and therefore my code, when I checked it in, removed that fix because I used my private version. So early 80s, we solved those problems. But the legacy is still here. Sorry.
I think it brings up an interesting challenge, Doug, because, you know, I mean, and maybe this is going to go down a rabbit hole. We can see if we want to go down it or not. But, you know, when we talk about regression tests, a lot of times you're talking about determinate type environments, right? And you're talking about, you know, hey, if I put these inputs in, right, I'm going to expect these outputs. And I think, you know, for many, well, decades, right? That's how teams have tested these types of environments. And I think the big challenge that AI gives us, right, is that it's not about determinant, right? Like now the software that you're testing is literally evolving on its own once it gets live, and it's responding to all different types of stimuli that are happening within the system, within the interactions that the users are putting in, with all kinds of different things. And so, you know, I think it is, when you start looking at the strategies that we've used historically, it feels like we're very ill-equipped at this time to be able to tackle those. And so I'm going to throw it out to this group here of smart people, and get your thoughts on that. Like, how do we, I know this is going to be a huge topic at CAST, because I think teams and individuals are feeling really lost in terms of how they get around this. And Joe, you mentioned it earlier, like, who owns that big picture of success, right? Who owns that? Whose responsibility is it at the end of the day to ensure that we're not producing crap, right? That we're not throwing garbage into our production environments and causing our users unnecessary pain. And that's, you know, the context is going to drive that pretty heavily, right? Like in a financial services situation where you're dealing with highly regulated environment, you're dealing with customers who are accessing funds. I mean, this is that's high criticality, right? When you're dealing with airplanes, you're dealing with cars, right? Matt, you brought up Tesla earlier. Like, these are incredibly high risk environments, and the tolerance for failure has to be small, right?
Well,
So how do
when
you
you raised a very critical point with respect to AI, and that risk is known as recursive self-improvement. So you create these AI agents that have an objective, but then on their own, they can create secondary and tertiary requirements in order to help them meet their primary objective. And that becomes a black box, and no one knows what's going on in this area of self-improvement. The AI is just trying to accomplish its objective and optimize its capabilities to accomplish the objective, but nobody wrote anything. Nobody created that. The AI created that itself.
Yeah,
That's a good point,
Yeah.
but I think you
One
should not
second. We'll come back to it. There's a question in the chat. I'll get back to you just right afterwards, Michael.
Sure.
Matthew.
Well, I think. Hi, everybody. I'm Matt Hausegger. I think that I agree with Joe to the extent that this AI stuff is not predictable, right? There's a term for it which escapes me on this morning when I haven't had my coffee yet, but it's not.
That's like a requirement for this, don't you know?
If we, I know it's the name of the thing. So, but I got here late, so it is what it is. So, but there's a you know, if you send the same problem to AI, the same open source AI twice, you're going to get a different answer. And even if you turn the randomness down so that because it's based on LLMs, which were designed to think like humans, which are random, even if you turn that all the way to 0, you don't know what you're going to get. And this is fundamentally different than C++ or Java or anything we had before, where we would figure out what bytecode we could get. If you could get a pencil and paper and figure out what you're going to get in the assembler or on the Java virtual machine, based on it was predictable. There was a set of rules, and those rules are out the window. I think that's a serious problem. The idea of recursive self-improvement, I am more skeptical on, because it's basically real, like the bootstrapping problem, where the AI just sort of gives itself higher IQ every day until it's super intelligent. It's just not really happening. It's never really happened. So I'm more skeptical of it. But we're getting the effect of that through having things like humans provide AI feedback in a neural net, which means it is better the next day and the next day and the next day.
Yeah, I think there's a term, hallucination loop, which is about the AI deciding something incorrectly and multiplying that problem. That we can't see it necessarily, but there have been some studies done, university studies, that fixing a bug, it progressively got worse. That the AI thought that it found the problem and it fixed it, except that it added problems. It didn't fix the first one, and we now have 2 problems, and that multiplies. And AI has a tendency to work a little faster than a person. And so it compounds that problem. It's something that's been a problem with computer systems and software. It can do the wrong thing bazillion times a second, and it just expands. And so an unsupervised AI, no human watching over it, can do a lot of damage when we give it the freedom to make changes.
Yeah. No, it's an excellent point. It's just, I want to go back to Michael. He was he had a couple points, and it's just like, and I have a question for him to keep the ball moving. And it's just like Michael, it's just like, can you have an example where the automated action did exactly what it was supposed to do and made things worse? That seems to be the general theme.
All comes back to context, right?
And it does.
AI is really bad at nuance.
Yeah.
Sure, I got a second one.
Okay.
No, coming back to context earlier, honestly, that's what I wanted to say before. I think we should not, or must not, or maybe not, that's wrong, should not bury the good old black box tests we were used to do all the time. As Matthew said it before, I just think they are going to change. Nonetheless, why did black box tests always work that good, the way they worked, as good they worked? Because they were judging a system purely from the outside, and therefore mimicking the real world. A user shopping on Amazon doesn't care if there is an HTTP 5.x, or doesn't care if there's the database is broken. A user on Amazon, when checking out, just cares, did it work or not? did I purchase my goods or not? Do I get them the next 2 days or not? So I think we should not bury black box tests at all. I just think they are going to change. Going to AI rubrics, context, technical context drift, and that stuff. And coming back to your last question now, Paul, the other example I can give from reality is, as we've seen, that microservices in the systems get configured that downstream microservice, so microservice A calls microservice B has household number now 2 seconds time to respond, and the system Kubernetes checks for that. And what we've seen, of course, in reality too, is that there was a subtle glitch, a subtle network problem, and then the system that was watching the microservice architectures started either restarting microservice B or microservice A, starting hammering on microservice B. The famous retry storm we saw in reality often with databases. Database doesn't respond fast enough, small glitch, and then microservices start hammering it again and again with the same question because of automated decisions made by the system. And in the end, the database broke down and entire banks went offline, or parts of banks. Does that answer your question?
Yeah, it answers it really well, and it's just like, and what I see happening, it's just like, it's the ground's shifting, and it's just like our systems, they just don't compute anymore; they act, and it's just like, in the dashboard that grades the action execution, it doesn't grade its outcome. So it's just like, and I think that's quite a pivotal, in testing on what's going on. And it's just it's been mentioned a couple times. We have a couple questions in the chat with an enhanced question. I don't know how to handle this. My first time moderating.
That's me throwing out a question to everyone, including those who are watching right now.
So I don't know how to answer.
I was adding on to the question that John asked earlier, right? Who owns that big picture of success?
And I think you. So I just point them to Gwen. Who owns this?
I mean, maybe in some contexts, I'll own that in some contexts, but not all contexts.
Yeah. No, it's just like, I mean, it's just like I would, if it's okay with everybody, I'd like to approach these big picture questions a little more towards the end, because it's just like there's something that's been mentioned a little bit, and I'd like to probe a little bit about this safety automation and counterfactual testing, and because we seem to be in an AI world, and these things are shifting and moving, and executions are not measuring the outcome. So it's just, Michael, could you just give a quick little segue into this topic of counterfactual testing, and where do you see it going?
Where do I see it going? Well, I consider it to be a very interesting field, and not only interesting field, I consider it to be absolutely necessary in the world of AI and AI agents that constantly give different answers and behave differently. Okay.
Mm-hmm. Yeah.
As I said before, black box testing is important because it mimics the real world. On the one hand, on the other hand, now with self-healing systems, self-remediation, AI agents, we don't have that clear computable numbers anymore. It is not. It is not anymore an 8-bit mask. It is suddenly a text that gets possessed or gets issued against a different system.
Mm-hmm. Okay.
And there are a bunch of systems.
Okay. So let
Was
me
the
kind
clear?
of,
Or
yeah. So let me just try to get a definition around this counterfactual testing. Joe, it's just like I understand it. It's just like we have two systems. I run the same test on system A and system B. Once with let's just say the AI is on and activated and just to get a control, and then the other side it says there's no AI activated. And then from this we can measure the outcome, whether the AI is activating properly or incorrectly. Am I correct in that? Would you add anything to that?
Yeah, no, that's accurate. You're looking at, a certain blast radius, so you've got a certain context for the testing that you're doing, and you're trying to make sure that if we put this change in place, if we add this AI or we add this new functionality, overall, are we going to have a good outcome? Maybe not the best outcome, but it's within control limits, so it's acceptable? Or are we going to have problems? And this is something that today, I think a lot of companies do this in production. They wait until something breaks down and oops, something went wrong, and then they have to go investigate it. But the damage is already done. Some internal or external customer has already been impacted. And you don't want to do that in production. That's, like we say in our
Typically,
marketing
no.
materials, that's quality assurance via hope, and I hope things don't go wrong. And what we're saying with counterfactual validation, with safety automation, is before you put something in production, make sure that there isn't going to be some kind of a negative implication that could impact end users. That's pretty much,
No, I think it's great. I mean, we've got a wrapper around this. My next question will go to Paul. And basically it's just like we're saying, let's test more productively earlier, and to understand the risk. As a person that's set in tons of meetings, approving budgets, and just saying, okay, now we might have to look at testing a little more extensively.
So thanks for coming back to me, Paul. So just a few comments, and I experienced all of this very recently working at Google Cloud, and more specifically, being on the teams that were rolling out AI type applications. Right, as Michael mentioned, the de facto answer to a problem, because I'm an ex-Googler, right? So Kubernetes was a big part. Microservices, Kubernetes were a big part of everything we were trying to roll out to customers, and customers were adopting microservices technology very, very rapidly. But that presented a huge problem, and the huge problem was this: something would go wrong, and the de facto response was, "Let's restart the systems." That was the de facto response, right? Now, as Gwen mentioned, right, what happened was it actually, the problems now expanded at the speed of quantum computing, right? Because everything we were doing in Google Cloud was some sort of quantum computing, right? We were running NVIDIA chips or whatever, and it actually expanded. It actually expanded the problem even further, right? So it created all these different problems. Ultimately, who was responsible on the business side was the business people. That's my own opinion, Gwen. Right? It was the business people that took the heat. And I'll just Doug mentioned working on software code with on punch cards, and I hate to admit it, Doug, but I actually know what a punch card is myself. I actually do know what that is. There has been it, and this is a pandemic inside the software industry, where they got applications, okay. And as Joe mentioned, they did at Cisco and lots of other companies. They run all sorts of testing, right? You know, UI testing, this testing, that testing, and that's all fantastic. But at the end of it all, I've been in so many meetings where somebody says, "Well, let's give it to the customers and see what happens. We're a bank. Let's roll it out. Okay, we're going to process. We expect to process 1 million credit card transactions a minute. Let's see how it goes." Right? Ultimately, they defer the actual testing to a live production environment. Right? So I think one of the things that Joe was talking about in safety automation is to find a way to address or alleviate that problem well before it happens, using some sort of counterfactual testing environment where you're not waiting for post-production to solve problems. Because when I was at Google Cloud, we had a core application. It was an API platform, and maybe some of you have heard it was called Apogee. And what was interesting about that is the Apogee platform would connect to databases, and it would connect one application to another way, which is the core functionality of any API. But that had a snowball effect if there was a problem. And guess what? We had no way to effectively prevent that or test against it. We just didn't. So what happened was there was a snowball effect to our customer support center. There was a snowball effect to our software development systems, right? Snowball effect to the teams working on the microservices in the Kubernetes environment, et cetera, et cetera, et cetera. So it's become endemic in the software industry that we have to, I think this core group that we have here can be a part of hopefully what we can change in the world today, is where we're not relying on post-production, right, to solve these problems, that we're doing it prior to, right? So I don't know, Paul, if I helped you out with that long-winded answer, but that's my 2 cents.
we used to call that beta testing.
Yeah, very good. Yeah, it used to be called beta. I think they still call beta testing though.
Well,
I've heard that. Alpha,
many
beta.
companies that aren't creating software for the mass market still do beta testing.
They still do. But most companies today still rely on, let's really test it in production. Yeah. Right. That's kind of like at the core. That's kind of what happens in the industry today.
Yeah, it's that fail fast, recover fast mentality.
Yeah.
I would agree, and it's just like, it's hard to get away from this fail fast mentality now. I mean, that's a part of our. It's an excellent question, Lee. I'm kind of looking in that right now. It's just like a lot of times it's just like organizations, they just want to do a little piece and a little piece and a little piece.
Yeah.
And the problem is you can't fire a rocket to the moon with just a little piece and a little piece and a little piece. You need the whole system to go. And sometimes that's really, 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 really hard to implement without having the actual rocket. And I think what we're looking at is saying, well, we have two alternatives, and we're looking at which two versions are better. One with, let's just say, an AI or an automation one, where the AI is making the decisions on behalf of whatever, the human, and the counterfactual is comparing the presence of that against the absence. So one is asking which version is better, and the other is asking, should this exist at all? Because we don't know. When it used to be beta, I don't know. Before in the beta, you would say, do we really need to do this at all? And I think each one of these are different questions, and they require different evidence. Just my 2 cents.
One other thing I'll point out is that a lot of software development is, almost all of it, is customer driven, whether it's an internal customer, an external customer. And we've all seen the request queues getting bigger and bigger and bigger. End users are waiting for these new capabilities to roll out. And so development teams are under extreme pressure to meet those requirements as quickly as possible. And I think that's what leads to sometimes biting off a little bit more than you can chew, and then leaving it to the end users to find out whether it meets their needs or not. And sometimes that means you're going to have big production problems that weren't anticipated. But a lot of companies, I don't understand it, but a lot of companies are okay with that model because they think they can recover quickly. And I guess it's good if you can, but it's not good if you can't.
Yeah. Well, and again, you know, in some cases that's fine. Like I think you guys were mentioning, you know, Amazon, right? Like, sure, you know, Amazon does, like an Amazon user is not going to care as long as they can go buy whatever they're going to buy, even if it's ugly. Where if you're in a healthcare environment, maybe not so great. I do want to call out Lee's thought here in terms of, you know, rolling it out a small subset at a time, because I think he's on to something that I don't think we've mentioned really, and that's something, you know, we can kind of learn from more of the cybersecurity realm, which, you know, if you look at cybersecurity, the way that they approach these very complex environments, these very complex problems, the variability of complex systems and the unknown threats, right, is they use a strategy called defense in depth, right? And, you know, yes, canary rollouts, certainly one thing to think about, right? If it's, you know, yeah, roll it out to 5% of your users instead of 100% to test it out. You have that capability today where we didn't have that. You know, it was a whole lot harder to do that 30 years ago. But I think today we have more tools than ever to, you know, yes, I think it's, yes, test earlier, right? Yes, test designs. Yes, think about implementation, think about monitoring, think about the logs that you're collecting, and think about the way that your models are going to drift over time and how you're handling that and how you're keeping a pulse on that, right? But it's also, you know, making sure that you have the right monitoring in place and that you're thinking about the way that you're rolling this stuff out, and maybe not going full in and diving into the shallow end of the pool, right? Like maybe you take a minute. So I think there's, you know, I don't know that there's, and maybe this is a challenge to everybody on the call here, right? I don't think that it's a silver bullet. I don't know that there's one strategy to really solving this problem. I think it's a combination of strategies because you are dealing with a level of complexity that demands it.
Yeah,
No, I would definitely agree with that. It's just like the level of complexity is increased, and I think that from, you know, building on Doug's point from earlier, when I create a regression case, I just proved that regression case worked. I'm still unaware of I don't know. There's like tons of heuristics that we can use to find different like frequency, intensive, business, legal, you know, opportunity threats. It's just there's so many different ways that we can look at a potential problem. To is this occurring? Is it not occurring? And it's just like, you know, and this is one of the things that I really enjoy about the black box software testing class is like we get this foundation of all of this knowledge that we can build upon to say, well, okay, what does the opposite look like? How would I set up a counterfactual test? If I have this in my hand as okay, I have this evidence. This is what I'm proving is green. But what else is around there? What is the secondary and tertiary problems? And I think that's quite interesting, you know, as we move forward in testing, because the ability to create test cases is, you know, it used to be really a thought-driven process. Now it's just like you plug an LLM into to a requirement, and you get an Excel full of test cases. It's just like, but it's just like, it's just, we still have to be able to analyze and look at what is the risk that is being validated. Is there value in that? Is there no value in that? And what if what if we don't do this test? Is the system going to survive? And what if this system starts thinking and acting for itself, and the human is completely out of the loop? What are our next steps there?
I think that historically, and I don't know today, but Amazon, Google, eBay used to roll out multiple new versions every day, and to a very small percentage of their user base. And the job of the tester was to monitor real time what's going on in the field, and where they found either users failing, basically, shut those machines down, reboot them with an older version that worked yesterday.
Mhm.
And so they were, in fact, and as I said, maybe today, rolling out to a very small percentage to check to see whether or not these changes were effective.
That's a very interesting point, Doug. The end user becomes the beta tester, basically. That's what you're describing, right?
Yeah, and the tester becomes a monitor of what's going on in the field.
Yeah. I think a trend that you're seeing as well is, especially when, dealing with AI components, what you're seeing is there's a lot more focus on when you're looking at, it's more theoretical testing, right? It's more thinking about things. And I think it goes back to what you were talking, and I think it was you, Michael, who brought it up, in terms of the non-factual, kind of really thinking outside the box up front, and going into these areas of, okay, what could possibly go wrong, and then creating the limits, right? And making sure that as you are deploying and implementing that AI model, the component, whatever it is that you're putting in place, making sure that the guardrails are in place to only give it what it needs and what it should have access to, and not just letting it go nuts, right? And not just giving it full reign to do whatever. And putting in, much like we have to do with humans, right? Like putting in, and Joe, like this is something, as a fellow governance person, right? Like this is something that from a GRC perspective, we do every single day, which is, you try to make it really easy for people to do the right thing, and you try to make it really difficult for them to do the wrong thing. And I think if you take that approach and you apply it to your AMI models, right, then you're creating the types of guardrails that give it the space it needs to be able to do its job and do its job well, but you're not giving it too much so that it causes issues and now puts the rest of your systems at risk. And I think that is a trend that you're starting to see in a lot of this, is that we're flipping it a little bit, and instead of testing an outcome, we're going, hey, what do we need to think about ahead of time, right? Like what access should these things have, and what rights should we be giving them, and what controls do we need to make sure that are in place before we roll this out, so that the drift is kind of contained.
Yeah, I think you identified something very important, but also something very challenging, because when you think about answering the question, what could go wrong, sometimes it's hard to come up with that list because you don't know what you don't know. And especially the more automation, orchestration you have incorporated into your architecture, that becomes even more difficult to answer that question, right? And then you have to think about, well, like when we did risk assessments, we looked at three things. What's the likelihood that it's going to occur? If it does occur, is it detectable? And if it occurs, what's the impact? So if it has a low impact and it's not likely to occur, then you can kind of, put it off in the corner somewhere as a corner case. But coming up with that list of what could go wrong, to me, that's a real challenge in today's automated modern architectures.
Oh, it is. And I think for anybody who's testing in today's world, it's a personal challenge. I mean, I think Lee just commented, right? We have to amplify creativity and really kind of change the way we approach testing. Change our strategy around what we test and how we test and what that looks like. And because one, the reality is we couldn't test everything before, right? We're sure not going to be able to do it now. So, we have to be risk driven. We have to think about the most important things. We have to think about these things before we put them in place. It encourages us to test early, test often, test in more creative ways, and think outside of, the test, the scripted, right? This kind of goes more to that exploratory, creative side of testing, which I think has been a little bit understated for a while. I know there are some of us who are big into it, but I think it's probably going to, have a rise because it's going to be a huge tool for teams to, and it's not just testers, right? I mean, really everyone needs to become the tester. So, it's not just one person's job, it's everyone's.
Oh, I think that's excellent. Excellent. I have one last question for Michael, and then I'm running towards the end. It's just like, and it's built on Gwen's statement earlier, where she said, you have to make it easy to do the right thing and hard to do the wrong thing. Let's just assume that on tomorrow morning you're with your development team.
Sure.
How would you approach that? This is the way. How would you convince them that this is a good idea? Or would you convince them that this is a bad idea? I would like to know how you would approach setting those guardrails. I mean,
Oh, you've stumped us.
A very
Michael's
natural
process.
argument is, as was said before, you have to treat it kind of like people, okay? I mean, make sure they can't do the wrong thing and make sure they can do the right thing. Or in ID security, they use...
We used to use white box testing
I only heard
to do that kind of thing.
Or in ID security, it is called perimeter security, one layer after the other, and make sure you have countermeasures on each and every layer, security layer, guardrail layer, and assume... Huh?
you assume what?
Short interruption, sorry. And I mean, assume that first parameters get penetrated, okay? So reduce the potential harm that can occur, as Gwen said before, like with people. Strange people you do not know, There was a small interruption again, I'm sorry.
It's okay. It's just, I think I get what you're saying.
I assume that things can go wrong, and build the appropriate countermeasures layer by layer.
Yeah.
Don't restrict everything, but make sure the correct check marks and checks and balances are in place. It's the same done in ID security. You do not install a database as a root user. It's intercepted.
Yeah, when you do a risk analysis,
that would be the arguments I bring. Do it like people, as Gwen said before, or do it like an ID security. Both strategies are well-renowned best practices used by.
That's great. You were saying, Doug?
Yeah, with FMEA, the failure effect and an analysis, basically. We analyze the risk
analysis,
which Joe talked about, and Michael. You analyze the risk, and there's 3 things that you can do once you've done that analysis. You can choose to accept the risk, you can figure out how to mitigate the risk, or you can say, no, I've got to fix this. So there's a risk-based approach to testing and development that could be applied, I think. With AI, the risks are unknown because the AI is making changes that we don't know about. And so we can't analyze what the risk is.
Well, that's.
I don't have a solution for that.
I don't think anyone does it, but it just it just brings us towards the end. It's just what we were saying. All the tests passed, which is true, and it's worthless. So I think we've kind of.
I take it back that it's worthless because that tells us it's ready to start testing.
Okay.
If we don't have all green lights, why test? It's failing.
Yeah. Oh, there's an idea. So green lights not meaning that it's ready to release, green lights meaning that it's ready to test.
Yeah,
I like that.
20 years ago, that's what it did.
That's a very interesting perspective. Very interesting.
Well, and if you look at counterfactual validation, that in essence is what we are doing. If something is green, okay, before we put it in production, let's run a scenario with it. Let's run a scenario without it. Let's see what outcome we get. And the counterfactual validation is not going to tell you what went wrong. It's going to tell you something went wrong, which means you have to go and do some investigative work to then pinpoint what created that problem. But at least it's problematic. And that's if you know that something is problematic, you might take you a little while to figure out where to look, but at least you're looking, and at least you know that prior to put it in production.
Yeah.
Wonderful. Okay, we're coming down to the last few minutes. I just want to go around and get the thoughts and ideas from everybody. It's just all tests passed, true and worthless. Paul, what do you think?
So I love Doug's perspective. I really did. I hadn't quite heard it like that before, and I really but I appreciate. I'm going to use it, Doug, in my presentations and take credit for it. Just to let you know.
You have my permission.
Yeah, listening to everyone here on the panel, it's really fantastic. I think the general theme coming out of this, Paul, is there has to be a way to do some sort of AI-based counterfactual testing prior to production, right? There has to be a way to do that without going to production and finding out what the problems are afterwards, right? I mean, I think that's kind of the takeaway. And this new category, which is being dubbed safety automation, a very broad term which can be applied here, definitely applies. So I think with the advent of AI, I think the future is very bright if we stay with it.
Thanks, Paul. Joe?
Well, for me, I mean, if you look at the amount of automation we have in our lives, apps on our phone, apps on our laptops, automation in general is just becoming a part of day-to-day living. And it's also becoming highly, highly complex. When I look at the business applications that I was involved with at Cisco, the level of complexity was incredible, and it only gets worse over time. It never gets easier because you're always adding, you're always extending. So I think as QA professionals, you're dealing with a level of complexity that is unprecedented and a volume of capabilities, automation capabilities that are unprecedented. So it's kind of a new era, and we have to figure out how to adapt to it.
Thank you, Joe. Michael? Thumbs up if you can hear me.
Not sure if Michael can hear you,
Yeah,
Paul.
I don't think so.
Yeah, Michael
Okay.
looks like he's not hearing anything.
Yeah. All right. It's just, technical problems happen to us all.
So
Gwen?
I'm late for my next meeting.
Oh, well then, Doug, let me just get to you first, and then let
Yeah.
you just jump out of here. I'll give you the...
I look at this with a historic perspective, and we've had to change paradigms over and over again.
I see it kind of like Joe in a little bit different terms, maybe.
1 second, Michael. 1 second, Michael.
The world got more complex in the last decades. Software got more complex in the last... Pardon me?
1 second. I'll get back to you.
Oh, now I can hear you. No, I'm here.
Okay. Just to finish up my thought, historically we've had to address this kind of problem over and over again, and I find that the test profession is very creative. We just haven't yet figured out how to approach this, and this discussion has been valuable for me, hopefully valuable for the audience, in looking at what are the problems and what are some ways maybe we can pursue to figure out a solution.
Yeah.
You hear me?
That's
Oh, I'm sorry.
Perfectly said. Thank you, Doug.
Yeah.
You have a nice meeting.
Thank you.
Bye, Doug.
You hear me? Sorry, network problems. Yeah.
Okay, now we're back to you, Michael. Or maybe we're not.
Yeah, I think Michael might be having some connection issues.
Yeah. So it's just like, Gwen, thank you very much for the slot and Caffeinated Quality. It's just I'll give over the last word to you, and maybe you can inform the viewers a little bit about the up and coming cast.
Yeah. So couple things. So, I think it's clear from this discussion that there's a whole lot more talking and a whole lot more problem solving that needs to happen in terms of figuring out the right strategies. Some of these are going to be localized. Some, each environment is going to be a little bit different, have its own nuance. But I think, we highlighted a few really, really strong points. And it just, to me, it just emphasizes why our profession is so cool. Our chosen profession is so cool, because we do get to have these types of conversations and challenge our thinking and bring different ideas to the table. But yeah, I mean, this is the big topic right now that everybody's discussing, right? And so it is something that we will be talking about at Cast. I promised in a promo that we would be putting a couple different deals up during this stream to get people to Cast. So we are Cast 2026 is on. It's a few weeks away. There is I think we have 19 days left till Cast, but there's still time to get there. If you guys want to join, and we're making it easier than ever for people to get there. So I'm going to share a couple of those. One of the biggest deals we've got right now is the Bring Your Buddy to Cast, because we want more people there. We want you there. So you save and your friends save, and we're really bad at math. So, well, not all of us, but when I was putting this together, it was, I think it was 2 a.m. So. But you save money, your friend saves money, you both get to go to Cast. It's beautiful, Cocoa Beach, right there on the beach. Who knows, maybe we'll even get a launch while we're there. I keep monitoring it because I'm hoping that while we're there will be something happening there at Cape Canaveral, but we'll see. And then the other one is we are also, and this is a 1 day only, so this is actually ending today. We have the beachfront bundle, which gives you both your ticket to Cast as well as your rooming for significantly cheaper than what you would typically pay. So we were just doing this for members, and it is only to members today. But the secret around this is there is a loophole. You can become a member today and still qualify. So get out there, get your tickets, because this conversation is going to continue there. We've got more experts coming to talk about this topic specifically. It will be a huge topic, not only of the tutorials that we have, but also just the talk in the halls, which oftentimes is the most memorable part of Cast. So get yourselves there. We want to see you. We want your voice. And also, big thank you to all of you for joining today. Paul, Joe, Michael, and I know we lost Michael there, but I'm going to give him a shout out anyway. Often we have these. I don't think we've ever done a stream where we haven't had at least one person have issues. So it's just the reality of streaming. But thank you all for your insights. It's been a pleasure to have you all with us. And, of course, anytime you guys want to join the conversation, we have these, typically once a month, but you're welcome. We love having you here. So thank you all.
Thank you
all for joining us on the chat as well, the live streams, those of you who are watching us. Love having the thoughts shared. Love having you all. Hopefully you've taken a few tidbits to think about for your week. And we'll see you next time.
Thank you. Bye, everyone. Thank you.
Bye, everyone.